And now, the 2015 Grand Award for Engineering Excellence in the state of Georgia. North Atlanta High School, presented by Uzun and Case, LLC.
In order to create the environment that the architects and the interior designers wanted, we had to cut openings in an existing slab. That slab was a post-tension beam slab system, so those beams had to be cut, and before they were cut, we had to detension the post-tensioning. The beams surrounding the opening, however, needed to be upsized, and we had to install external post-tensioning. This system is not very easy, and it's complicated, so the design was a multi-step design, taking into account the existing post-tensioning and the new post-tensioning that we would put on the exterior. Due to architectural constraints in the atrium you see behind me, we were limited in the locations where we had to place our steel brace frames. In order to mitigate and reduce drifts to an acceptable level, we required additional lateral framing members. The architects designed an exposed concrete trellis system that you also see behind me. So in order to gain lateral stiffness in the building, we utilized these in part of our lateral system. However, the challenge then became, how do we transfer forces between the steel system and the concrete system? So what we did was design a specific channel connection to the steel roof framing members that allowed easy forming and efficient transfer of lateral force through the slab system into the concrete trellis system. In order to make efficient use of the site, the gymnasium was sunk down and placed on bedrock. To reduce the amount of rock that needed to be blasted, we had to create a proprietary and special retaining wall called the narrow backfill wall. However, this narrow backfill wall needed rock anchors because the heel length was short. So we lengthened the toe, and on the heel side, we placed rock anchors, grouting rebar into the rock to prevent uplift on the back. This narrow backfill wall design saved thousands and thousands of cubic feet of rock blasting and was able to create an effective use of the gymnasium. Due to the site geology, one half of the gym is placed on bedrock, utilizing the narrow backfill walls. However, this side of the gym is 20 feet to 30 feet above bedrock. So what we needed to do then was to post down piers to bedrock. However, due to the presence of lateral system, multiple brace frames in this area, that pier system was required to be a lateral system as well. So we created a moment frame with the piers and grade beams spanning from column to column and pier to pier to create a system that could properly and adequately drag the lateral force of the building to the foundation and the bedrock. The challenge, however, was the transition between the pier system and the on-bedrock system. So what we did was span grade beams from the pier system to the foundations that were on bedrock to create a cohesive system that would not experience differential settlement. In order to properly light the stage for the auditorium, there was 2 catwalks that were required to span across. These catwalks hung from long span joists above. However, the hanging connection and the lateral system to prevent them from swaying got really complicated very quickly. We ended up hanging the system and the catwalk from the long span joists using HSS tubes, and then providing braces, cross braces, on the catwalks to prevent the sway. The loads the system was required to carry were not substantial, but for the hanging tubes and the long span joists, they became an issue. So we had to connect the tubes at both the top and the bottom of the joists in order to properly transfer the load.